This question was asked in 2014. State the Coulomb's law of electrostatics and express it in vector form. Okay, so let me answer this question. Coulomb's law states that the magnitude of force of attraction or repulsion, the magnitude of force of attraction or repulsion between any two point charges at rest is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the two charges. Okay, so this is the Coulomb's law, right? So hope you have understood the statement of the Coulomb's law. So let me explain what does it mean. Just wait. And just let me put it here. Okay, so this. Okay, now you see, I'm gonna express it in vector form as well, but before that let me explain the statement. Suppose we have two charges q1 and q2 and they are separated by a distance r, suppose. Then the force of attraction or repulsion, depending on the nature of the charges, that force is directly proportional to the product of the magnitude of their charges, and it is inversely proportional to the square of the distance between them. This is what all about Coulomb's law. Now let me express it in vector form. So Coulomb's law in vector form. Okay, so let us consider two charges q1 and q2. These are the two charges q1 and q2. So their position vectors are supposed respectively r1, and this position vector of q2 is suppose r2. And let me take the displacement vector from q1 to q2 is r12. Let me write this one as r12. And if you take this displacement in opposite direction, that's let it be r21. Okay, now you see, if you apply the triangular law of vector addition, you see r1 for this displacement, r1 and r12 are in the same order and r2 is in opposite order. So that's why, so we're gonna have r1 plus r12, the resultant gonna be r2. And if this is the case, then we can write r12 is equal to r2 minus r1. Similarly, for r21, if you want to find r21, that's going to be r1 minus r2, right? So hope you know these things. These are very basic things. Okay, so let me write what I have considered here. So here what we have done, we have considered q1 and q2 be 2 point charges of same nature. That means either both are positive, both negative, with position vectors r1 and r2 respectively relative to some origin O. Okay, so now let me consider that force exerted by q2 on q1 be, suppose, let me write it F12. The force experienced by charge 1 due to q2, that will be directed in this direction. The force direction of this force will be this way, away from each other, because I have considered the force is I have considered the two charges are of the same nature, either both positive or both negative. So force of there should be a force of repulsion between them, okay, not attraction. So, and in this direction, let me consider the force experienced by the charge 2 q2 with respect to charge q1. So let it be f21. Okay, so let me represent it that way. So let the force F12 is the force experienced by q1 due to q2 and F21 is the force experienced by Q2 due to Q1. Okay, so then according to Coulomb's law, therefore according to Coulomb's law, this F12 that must be equal to, let me mention one more thing, that just one. So R12 is equal to, so what we have done, we have taken here R2 minus R1. So here it is the initial position vector and R2 is the final position vector, right? And R21 vector is equal to R1 minus R2. Let us suppose that way. And one more thing, R12 is negative of R21. Okay, the magnitudes are same but they're opposite in direction, right? So now according to Coulomb's law, F12 that should be equal to 1 by 4 pi epsilon naught magnitude of the charges Q1 and Q2, magnitude of the product of the two charges, divided by, square of the distance between them, right? Square of the distance between them. So here in this case what I have done is, I have taken the force F12, its direction is this way. Here you can see direction of F12 is same as the direction of R21. That's why I have written here R21, and I have taken the magnitude only, so direction will be given by the unit vector of R21, right? So where R21 is the unit vector of R21 vector, R21 cap is the unit vector of R21 vector, right? Hope you know these things, right? It's a vector. Okay, so it can be written this way. R21 vector is nothing but R1 minus R2 that I have already given here. Let me clean these things. R1 minus R2. So that's why I have used this value here. Then magnitude of R21, that is nothing but magnitude of R1 vector minus R2 vector, right? So that's what we can do. So then if we replace this 2 with this result, then what we're gonna have? Just wait, let me write this one here. So now let us replace this one by this, and let us replace this one by here you see this. Okay, so then what we're gonna have, so let me copy these things and just wait, let me copy this and let me take a new slide here. So this is the last step we have got. You don't have to repeat this last step, okay? Just as I have taken the new slide, so that's why I have taken this one. So let me copy the diagram as well, just wait. So here, okay, so now R21 vector is nothing but R21, this is R21, sorry, not this one is R21, from this direction to that sorry, from this one to that one, Q2 to Q1, that is R21. So here final position vector will be R1, so R1 minus R2, right? R1 minus R2. So then 1 by 4 pi epsilon naught F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by, so let us replace this by this. Okay, so then what we're gonna have here, r1 minus r2, mod of r1 minus r2 here is square. Then let us replace this by this value. Then what we're gonna have, r1 minus r2 vector. Okay, just wait, and divided by minus mod of r1 minus r2 vector, r1 vector minus r2 vector. Okay, so here 4 pi epsilon naught, what we're gonna have here, if you multiply these two, then you're gonna get here r1 minus r2 mod of r1 minus r2 cube, here q1 q2 into, sorry, here r1 minus r2. So here this is vector. Okay, so don't use here modulus, okay, because if you use modulus, that's going to represent magnitude. So this is vector. Okay, we have to keep this one as vector. Okay, so this is the vector form of Coulomb's law. This is the vector form of Coulomb's law, right? And similarly you can find F21. So if you take F21, then your expression gonna be equal to q1 q2 by, here these two should be altered. Here it is magnitude only, you can keep this one in the same order, but you have to alter this one. Okay, so just wait. So here what we can write, r2 vector minus r1 vector, so that should be cube here. Then here r2 vector minus r1 vector. Okay, that's what we're gonna have. Now what is the relation between these two? Now you see, this is r1 minus r2, this is r2 minus r1. So if you take a minus common here, then this expression, this can be expressed in this way, 1 by 4 pi epsilon naught, that is q1 q2 by mod of r2 minus r1 and now you see mod of r2 minus r1 and r1 minus r2, that's going to be same because it is magnitude only, right? So we can write r1 minus r2 cube. So if you alter this, then what we're going to get, we have minus here, r1 minus r2. So this part is nothing but f1, right? So this is equal to minus f12. So what we can write, that f21 is equal to negative of f12, right? So that means these two forces are equal and opposite, right? So hope you have understood this. So thank you for watching. See you in the next video. Please share with your friends, inspire me to create new contents for you, and help me to grow my channel. Thank you.